Hi, it's Mrs. Martello. We're going to continue in section 7.6, and here now we're going to solve our equations by factoring and using the zero product property. We have that a in front, ax squared plus bx plus c equals 0. So again, we're using the zero product property. Let's remember our steps. First, the equation must be equal to 0. Second, it must show a product. So in order to get a product, we're going to have to factor it by making that table. Then finally, we can solve each factor. You set each factor equal to 0 and solve. We're going to do 2 examples, and these are coming from the exercises from 7.6 on page 395, in case if you're wondering where I'm getting these from. We're going to do numbers 25 and 27 all the way down here at the bottom. So let's start with number 25. Number 25, I have 5x squared minus 5x minus 30 equals 0. Okay, we're going to solve this equation. Our first step is that it's equal to 0, which is awesome. I don't need to worry about that. Our next step is we're going to factor so that this becomes a product. Remember, when we factor, we always want to look for a GCF. This one does have a GCF. Our GCF of all of these numbers would be 5. So let's take that 5 out. We're going to be left with x squared minus x minus 6 and then equals 0. All right, so now we're going to factor this expression inside of here. All right, let's make our table. The product is x squared for the first term. The second product is negative 6 for the last term, and our sum is negative x. Remember, this is outers plus inners. Okay, let's find our numbers that are going to make this work. I know I have to do x times x. If my product is negative 6, I want one negative number, and I want a sum of negative 1x. So I'm going to do negative 3 and positive 2. If I look at my outers and my inners, this would be 2x minus 3x, which does equal negative 1x. Okay, so let's factor it. Don't forget about the 5 in the front. We're going to have 5 times x minus 3 times x plus 2. And don't forget, equals 0 here at the end. All right, so now we're done factoring. We're ready to solve. We're going to set each factor equal to 0. This first factor is just 5. It doesn't have a variable, so I can't set it equal to 0 because 5 will never equal 0. So I don't need to do anything with this one. I'm only going to use the factors that have x's in them so that I can find out the unknown value. So we're going to say x minus 3 equals 0, or x plus 2 equals 0. We're going to solve. We'll add 3 to both sides. We get x equals 3. That's our first answer. Subtract 2 from both sides. We get x equals negative 2, and that's our second answer. Okay, remember, you can always check your work by taking these two numbers and plugging them in one at a time. We can even plug it in our calculator. Let's see what it looks like when I plug in each one at a time. So we're going to plug in 3 first into the original equation. 5 times 3 squared minus 5 times 3 minus 30 equals 0. That one works. Let's try to plug in negative 2 now, again, into the original equation. Make sure that one works. 5 times negative 2 squared minus 5 times negative 2 minus 30, and that one also equals 0. So I know these both are the solution. Okay, so that's number 25. Let's do one more like this. We're going to do number 27. Okay, number 27, I have negative 12n squared minus 11n equals negative 15. Okay, in this equation, it is not equal to 0. So that needs to be my first step. I want my equation to be equal to 0. So let's add 15 to both sides, or I could go the other way and I could try to get my a term to be positive because I know the a has to be positive. If the a is negative, then I would have to factor out a -1. And that's totally up to you, however you want to do it. I personally think it would be easier to move the first two over to the other side. Let's make these positive by adding them to the right side. So I'm going to add 12n squared and I'm going to add 11n. We'll do the same thing over here, plus 12n squared plus 11n. Let's write our new equation. We have 0 equals, make sure you put them in the right order from highest degree to lowest degree. 12n squared plus 11n minus 15. All right, so now our equation is equal to 0, and it doesn't matter that the equal 0 is on the left or if it was on the right, it doesn't make a difference. We're ready to solve. We're gonna make our table. This is our ax squared, bx plus c. So we have a product of 12n squared. We have a product of -15, and we have a sum of 11n. Okay, let's see. Well, I know that I need to get a positive 12n squared. There are a number of different ways that I can do this, so it's just trial and error. Let's try to figure out the best way. What if it was n and 12n? Let's see if I can make this work. If I have a negative product here for the second term, then I need one negative number. Let's see if I can make this -1 and 15. The outers, that would be 15n, and -12n, that doesn't work. If I switch these, 12 times 15, that would be way too much. Let's try different numbers. We're gonna try 3 and 5. -3 and 5, let's see, this would be -3n, and this would be positive 60, oh sorry, we're going to do outers. This would be 5n minus 36n. That's not going to work. What if I switch these around? -5 and 3. This would be 3n and -60. That's not going to work either. Why don't we try switching these numbers in the beginning? Maybe they need to be 2 and 6. So we'll try 2n and 6n. Now let's see if this works. Our outers, this would be 6n. This would be 30n. That doesn't quite work. Why don't we try it around the other way again with 3 and 5. This would be 10n and -18n. That's not going to work either. Maybe we'll try different numbers in the front here. Let's try 3 and 4. So you see how I'm just trying to go through different combinations? Let's see if this one works. This is going to be 15n and -12. That's not going to work. Even if I switch them, if I make this -5 and 3, that would be 9 and -20. Oh, we're getting closer. That would be -11, but I want positive 11, so let's switch which one is negative. We're gonna keep positive 5n and we'll do -3n. Let's try this. So now this is -9n and this is positive 20n, and that does equal 11n. So that one was a lot of trial and error. The more factors that this first term has and the more factors the second term has, the more options there are. And you really just have to stick with it until you find the right combination. Okay, so let's write our expression factored. Don't forget the 0 equals. We have 3n plus 5 times 4n minus 3. And of course, equals 0. Okay, we're gonna solve. Let's set each of these factors equal to 0 and we'll solve. 3n plus 5 equals 0, or 4n minus 3 equals 0. Let's solve for n. In our first equation, we're going to minus 5 to get 3n equals negative 5. We'll divide by 3. N equals negative 5 over 3. That's our first one. Our second one, we're going to add 3 to both sides. 4n equals 3. Divide both sides by 4, so n equals 3 over 4. And that's our second answer.